Militaries have often pushed the boundaries of technology in their desire to develop faster, more accurate, and more lethal weaponry. Yet the way we hurtle projectiles into targets has actually changed little since bows were supplanted by guns and cannons. Conventional projectile weapons largely all use pressure from ignited gunpowder or other chemicals to propel projectiles out of a barrel. But a new type of projectile weapon being developed could upend the use of traditional weaponry. Enter the electromagnetic railgun. Railguns use electricity and magnetism instead of gunpowder and pressure to accelerate projectiles down a set of rails at hypersonic speeds. Projectiles launched via railgun generally reach speeds of around 5,500 miles per hour, Mach 7. For comparison, the fastest bullets can travel around just 1,800 miles per hour. In fact, railguns deliver projectiles at such speeds that they have no need for explosives. Railgun projectiles on their own deliver so much kinetic energy on impact that they can deliver more destructive force than an equivalently massed explosive projectile, and at a fraction of the cost. The basic principle behind a railgun is that it uses an electric current to create a magnetic field. A railgun is made up of two parallel conductive rails. Current travels from the power source up to one rail through an armature holding the projectile, which acts as a connecting wire, and back down the other parallel rail. The more current that is pumped through the system, the more powerful the magnetic field, and the faster the projectile will go. Like a charged wire in an electric field, the projectile experiences a force known as the Lorentz force, which is directed perpendicularly to the magnetic field and to the direction of the current flowing across the armature. By directing the net magnetic field between the rails vertically, the projectile can be sent hurtling at stunning speeds. Railguns have a number of advantages in addition to the speeds at which they can fire projectiles, as they don't need to carry an internal propellant or explosive charge. They are much cheaper to manufacture and safer and easier to store and transport. The lack of explosive is a particular advantage at sea, where an explosive can mean the destruction of an entire ship. So why aren't we seeing railguns used by militaries everywhere? The answer is that railguns also have a significant number of disadvantages. More current means more speed and force, but this also translates to excessive amounts of heat. The heat produced inside a railgun is so extreme that it requires constant changes of the rails due to wear and tear. This is a big problem because for a weapon to be effective in modern combat, the barrel must be able to fire continuously without malfunction for an extended period of time, while many types of heavy artillery can fire up to 600 times before needing repairs. Railguns can only fire a handful of times. Railguns also require an enormous amount of space. This makes them difficult to install on all but the largest vehicles. As of 2021, there are only 3 ships in the U.S. Navy large enough to carry a railgun. On top of this, the guns currently have a range of just 50 to 100 miles. That puts the vessel carrying the weapon well within the range of many conventional longer-range weapons. Another big problem is that these weapons require so much power that firing them essentially requires energy to be drawn from the craft's propulsion system. The guns being developed require around 9 kilowatt-hours of energy per shot, and very few vessels are capable of supplying that kind of power. Due to these hurdles, the U.S. Navy has recently ceased its railgun development program, opting instead for hypersonic weapons. Others are still working on the technology, and in the future, advances like supercapacitors could help with some of the issues. Railguns have also been proposed as a way to launch cargo into space. Who knows? In the future, we may see railguns given new and even non-lethal uses.